Welcome to Study Loop.
Hi friends, here it is given. A non-ideal vapor compression. A non-ideal vapor compression refrigeration cycle having working substance R134A. We have to find A part, quality of fluid at the end of throttling process. B part, coefficient of performance, input power, and irreversibility rate. Associated with compression process are to be determined. Let us see here the analysis. Refrigerate enter the compressor as saturated vapor at evaporated pressure and leaves the condenser as saturated liquid at condenser pressure. Using refrigerant table A12 and A13, pressure P1 140 kilopascal, fluid saturated vapor, heat capacity or thermal capacity at the rate of 140 kilopascal, 239.19 kilojoule per kg. Entropy to be at the rate of 140 kilopascal, 0.94467 kilojoule per kg per Kelvin. Pressure P2 0.8 megapascal. S saturated equal to S1. Heat capacity at saturated state 275.4 kilojoule per kg. Carnot efficiency calculation for part A. Carnot cycle efficiency H2S minus H1 upon H2 minus H1. From here we can write H2 to be H1 plus H2S minus H1 divided by efficiency of Carnot cycle 239.19 plus 275.4 minus 239.19, and Carnot efficiency is given 0.85. So on solving it, H2 you will get 281.79 kilojoule per kg. Now P3 is equal to 0.8 megapascal. Fluid is saturated liquid. H3 is equal to HF at the rate of 0.8 megapascal, 95.48 kilojoule per kg. H4 is equal to H3, 95.48 kilojoule per kg. That is the throttling process. The quality of refrigerant at the end of throttling process X4 to be H4 minus HF upon HF at the rate of 140 kilopascal. Substitute the value 95.48. All the parameters given above, just you have to substitute them. 281.79 minus 239.19. So quality factor of fluid you will get. Quality factor of fluid at the end of throttling process you will get 0.323. This is the answer of part A. Now we start solving the part B. In part B we have to find coefficient of refrigeration. It is defined as heat transfer to the low temperature divided by work input. So it will be H1 minus H4 upon H2 minus H1. Substitute the value, you will get 239.19 minus 95.48 upon 212.13, that is 0.323. So quality of performance is 0.323. In part C, we have to calculate work input. So work input will be rate of flow of heat at low temperature to coefficient of performance of refrigeration. So 5 kilowatt upon 3.373 is equal to 1.48 kilowatt. That's all for it. Thanks for watching it.